Okay, so here's our projectile motion problem. There are like 4 parts to this, so I'm going to try to do it all in one video, but a ball is projected directly upward from an initial height of 100 feet. Okay, so that's going to be your S naught, okay? With an initial velocity of 80 feet per second. That's going to be your V naught. So what does the formula say? S of t is equal to negative 16t squared plus V naught t plus S naught. So our formula is going to be S of t equals negative 16t squared. The initial velocity was 80 feet per second, so 80t and plus 100. Okay, so that's our formula right there. That's the one we're going to use. After how many seconds does the ball reach its maximum height? What is the maximum height? So we want to find the vertex. Let me see if I can get it back there. The vertex for that formula. So we can use the vertex formula, right? All right, so the vertex formula is going to be negative b over 2a, and then we'll have to plug that in, S of negative b over 2a. Okay, so negative b over 2a is going to be negative, oops, I don't want to write it that way. That's going to be, this is your h, that's going to be negative 80 over 2 times negative 16. And when you work that out, you get 2.5, okay? So that's what it happens to be. And then you have to plug that in. So you're going to take S of 2.5 and you're going to plug that into the formula. Plus 100. Okay, so negative 16 times 2.5 squared plus 80 times 2.5 plus 100. You should be able to put that into a calculator without too much trouble. When I did this problem, I actually completed the square, but I think it's probably easier to do it this way. Okay, when we do this then, S of 2.5 winds up being 200 feet. Okay, so this is seconds here. So you're throwing the ball up, right? I think that's what we were doing, throwing a ball up. Let me see. A ball is projected. Okay, so we're throwing a ball up. And after 2.5 seconds, it's going to reach its maximum height of 200 feet. All right, so let's read the question. After how many seconds does the ball reach its maximum height? So 2.5, that's when it's going to reach its maximum height. And what is the maximum height? 200 feet is the maximum height. Maximum height after, I guess you could make a sentence, after 2.5 seconds, ball reaches max height of 200 feet. I don't know how you want to say it. Okay, that's that idea. For what interval of time is the height of the ball greater than 160 feet? So you have to take your function, negative 16t squared plus 80t plus 100, or 100, yeah. That has to be greater than 160. Okay, so we're setting up an inequality here. This is a quadratic inequality, and we've worked on those. So negative 16t squared plus 80t, and then it winds up being minus 60 is greater than 0. When I did this problem, I said, oh, all those numbers are divisible by negative 4. I wanted my leading coefficient to be positive. I was hoping it would factor, but it doesn't factor. Anyway, so you get 4t squared minus 20t plus 15. And you want to know when that's greater than 0. So you have to go to the quadratic formula for this. How much room do I have? A little bit. Okay, so the opposite of b, which is going to be 20, plus or minus, and then you're going to go 20 squared minus 4 times 15, and all of that's going to be over 2 times 4. And when you do that, you wind up with a simplified form. So I'm not going to put all the steps in. I probably should. Okay, so let's do a little bit here. Where can I go? Up here. You're going to get 20 plus or minus, and then you're going to have 400 minus, I did it on a calculator. Let's see, 240, I think. So 16 times 15. I did it all on a calculator. Anyway, yeah, over 8. And then I had 20 plus or minus square root of 160 over 8. And that's simplified to be 20 plus or minus 4 times the square root of 10 over 8. And you could divide the 20, the 4, and the 8 all by 4. So that turned out to be 5 plus or minus the square root of 10 over 2. Now, that's what it is in a simplified exact form, but we really want a decimal approximation here. And so the two approximations are when you do the subtraction, it's 0.92. And we're going 2 decimal places on these. And then when you do the addition one, you get 4.08. So on the number line, I'm going to run out of room again, but on the number line, here you are at 0. Here you are at 1, and let's say here you are at 4. That 0.092 is like right there, 0.092. And then over here is like 4.08. Now, you're not going to include those. And you're going to think of a number between there to try and see if it works. Well, probably the easiest number is the 1 right here. Use that 1. Oops, there goes my 1. Put the 1 in and see if that's going to be greater than 160. And it is. And so it's this section that works. So the interval is from 0.92 to 4.08. That's when the ball is higher than 160 feet. Okay, so it takes almost a second for it to get up to 160 feet, and then it's going to stay that height. It's going to be that height or higher, and then it's going to start coming down, and then at 4.08 seconds about, then it's going to be falling below 160 feet. Okay. After how many seconds will the ball hit the ground? So then what we have to do is we have to take that equation, negative 16t squared plus 80t plus 100, and say, when does it equal 0? That's hitting the ground when the height is 0. And those were all divisible by negative 4 again. So I got 4t squared minus 20t minus 25. It just made the numbers smaller for me to work with. Then I was really hoping that one would factor, but it didn't. And so I got something like 20 plus or minus, I had the square root of 800 over 8. And that's simplified to 20 plus or minus 8. No, it didn't. That's a 10. It's a 10. Actually, should be a 20. 20 times the square root of 2. So you'll have to do some of those intermediate steps using the quadratic formula over 8. And then those were all divisible by 4. And so I got 5 plus or minus 5 square root 2 over 2. I put that in a calculator, and it was 6.04 seconds. Now, if you have trouble with the calculator, and I was just using my calculator on my phone because I can never find like a good calculator at my house. If you have trouble with the calculator and getting these answers or trouble with the quadratic formula, stick around in the support class and I'll help you with that. Okay, so that's how that last problem works. Example 6 is optional for you to look at. I did not do a video for it. It involves using a graphing calculator and you're not required to have that for this course. So if you're interested, you can watch the video that's provided in the e-text. Yeah, that's all I'm going to say on that. All right, if you have questions on this, we can try to spend a little time going over things, but we'll have more material to cover in class when we meet Thursday. So